Another very powerful tool that is available to us as we solve quantitative problems is something called dimensional analysis. And its name kind of tells what it is. It's analyzing a problem by dimension. Dimensions is just another name for units. This is sometimes also called the factor label method or the unit factor method. It goes by different names. I'll probably call it dimensional analysis more often than not. This is often introduced as a way of just converting between units, like miles to kilometers or something like that. And nowadays, that's not so useful because we have a lot of electronic ways of doing that. However, it's still an extremely valuable technique to know because it's really good for anything that's proportional. Like if you could solve a problem by stringing together 5 or 6 or 7 proportions, you can do that in one quick step using dimensional analysis. So this is a very powerful tool. In addition to analyzing, planning, computing, and evaluating, dimensional analysis is the single most important tool in my whole arsenal for solving quantitative problems. Dimensional analysis operates on the basis of 2 simple mathematical facts. One of them is that dividing any quantity by itself results in a value of 1. So if we think about a few examples, 5 divided by 5, well, that's 1. But by the same token, 2 plus 3 divided by 5 would also be 1 because 2 plus 3 is 5. Or 5 divided by 4 plus 1 would be 1 because 4 plus 1 is 5. So therefore, 2 plus 3 divided by 4 plus 1 would also be 1. Now here's how we use this in dimensional analysis. We think about things like 2.54 centimeters is equal to 1 inch. So that means if I take 2.54 centimeters and I divide it by 1 inch, well, that's just 1. Or 5,280 feet is the same thing as a mile. So if I take 5,280 feet and divide it by a mile, that's 1. The other simple mathematical fact that dimensional analysis relies on is that multiplying by 1 never changes the number. It never changes the size of a piece of data. For example, if I had 5 and I multiplied by 1, I would still have 5. If I multiplied 5 by 1 as many times as I cared to write it down, I would still have 5. So maybe I could do this. If I had 5 yards, I could multiply by something that I know to be 1. 1 yard divided into 3 feet. 3 feet and 1 yard are the same. If you divide something by something that's its equivalent, you have 1. So I multiply 5 yards by this quantity, I have multiplied by 1, which means I still have the same length that I always had. But here's what changes. Because yards cancel out, being on top and bottom, I've converted my number into feet. And when I multiply 5 by 3, I get 15. Well, that's a very simple example, and you don't need dimensional analysis to do that. We'll look at a few other simple examples as well. But sometimes the problems get much more complicated than this, and dimensional analysis can become a very important tool for making conversions that aren't trivial like this. Here's an example of how we can use dimensional analysis to change units. If I want seconds to change into minutes, I can use this factor. I make sure that I put the seconds on the bottom here because it's already on the top and I want it to cancel. And I make sure I put minutes on the top because that's what I want to end up in my answer. So what happens? Seconds cancel out. They do not appear in my answer. Minutes do, and when I've set this up so that the units come out right, the number will automatically come out right. 15 divided by 60 is 0.25. I can stretch this out even further if I want to. If I took 15 seconds and I wanted to convert it all the way to hours, I could do this. Multiply by the 1 minute over 60 seconds, but then I also know 1 hour is the same as 60 minutes. So if I multiply by that factor, I haven't changed the quantity. I just multiplied by 1 again. But minutes cancel out, and now my units come out in hours. If I do the arithmetic, it's 15 divided by 60 times 60. And stretch it out even further. Many, many steps. I can go from seconds all the way to years by just multiplying by things that I know are equal to 1. Like 1 minute over 60 seconds, we've done that already. That gets rid of seconds. 1 hour over 60 minutes gets rid of minutes. 1 day over 24 hours gets rid of hours. 365 days under 1 year gets rid of days. every one of these factors that I'm multiplying by is equal to 1. So I'm not changing the size of the time. I'm just changing what unit I'm expressing it from seconds into years. Try this one. I'll give you a little factoid that you can work with. 2.54 centimeters is the same thing as 1 inch. And then you'll probably recall that there are 100 centimeters in 1 meter. Now, using these little facts, stop the video and try and convert by dimensional analysis. Okay, here's your answer. I'm going to start out in dimensional analysis. Good plan is always to start out by just writing down what you know, making an extended line like this, and then writing down your target unit. What do you want to get to? Well, I want to get to inches. I know that 2.54 centimeters is an inch, so if I can convert these meters into centimeters, that will do it for me. Well, this factor will allow me to do that, so I'll plug that in next. I want the meters to go away, so I'll put the 1 meter part of this on the bottom, and I want centimeters to be in my answer so that I can get rid of those with the other factor. So I'll put 100 centimeters on the top. With meters canceled out, I now have my length in centimeters. If I were to stop here and multiply, I would have centimeters. But I'm not going to because I'm changing to another unit. I want centimeters to go away, so I'll take the 2.54 centimeters from the next factor and put that on the bottom. And that's equal to 1 inch, so I'll put that on the top. Again, I've only multiplied by 1. It's still the same length. But now that centimeters are canceled out, inches are in my answer. Now I just do my arithmetic. 2 times 100 is 200, divided by 2.54 comes out to 79 inches to two significant figures. I'm going to have you try this one, but before I do, I'm going to give you a few pointers. First of all, some factoids that might be useful here. Again, 2.54 centimeters equals 1 inch. That might be useful. A lot of people forget this one. 5,280 feet is 1 mile. That may be useful here. And then, again, 100 centimeters is 1 meter because a centimeter is a hundredth of a meter. Then here's another thing that might help. When you see the word part per, that really means divide by. So 13 meters per second could be written 13.0 meters over seconds. Use that as a starting point and see if you can figure out this problem. Stop the video. I'll give you the answer in a bit. My starting point is 13.0 meters over seconds. My target unit, somewhere over here, I want to end up with miles over hours. How am I going to get there? Well, miles is in the English unit system, and the only factor I have here that will help me with that is 2.54 centimeters is 1 inch. So I want to take this meter unit and change it into centimeters. That's pretty easy to do because we know there are 100 centimeters in 1 meter. So the meter part cancels out with only this factor. Now I'm in centimeters. How am I going to get that to English? Well, with this factor. 2.54 centimeters is the same thing as 1 inch. So now I'm in the American or English system of measurement. Everybody knows that there are 12 inches in 1 foot. So these are equivalent to each other. So multiplying by that factor doesn't change the speed, but it does change the units. If I were to stop here, I would have feet over seconds. That's what I'd have left. But I don't want feet, I want miles, so I'm going to multiply by another factor, and that is that 5,280 feet is the same thing as 1 mile. Now, if you look at what's going on in the numerator, I have only miles left. That's it. But in the denominator, I don't have the unit that I want. I have seconds. So now I'll start working on that. Here's something everybody knows. 60 seconds is the same thing as 1 minute. So I can cancel off my seconds by multiplying by this factor. Since 60 seconds is 1 minute, I haven't changed my speed, but now it's miles per minute. I can get rid of minutes with this factor. 60 minutes is the same thing as 1 hour. Well, that's the final step because I have now canceled off everything on the top except for miles, and that's my target numerator unit, and everything on the bottom except hours, and that's my target denominator unit. At this point, I want to show you something on your calculator so you can avoid some mistakes, and it has to do with how your calculator does operations. It might not necessarily do what you want it to do. So let me clear this calculator out. And I'm going to do this calculation two different ways so you can see that you get a different answer. Just follow along here. First, I'm going to go 13.0 times 100 times 1 times 1 times 1, but I don't have to put those in there because they're just ones, times 60 times 60. So I've gone all the way across the numerator now. If you're following along with the numerator, it's 13 times 100 times 60 times 60. And actually, when you're doing the calculations, you don't have to put the 0 in the 13 because your calculator doesn't know from sig figs. Now I'm going to hit divide by, and then I'm going to divide by everything in the bottom. So it's 1 second, so 1 times 1 times 2.54, so 2.54 times 12 times 5,280 times 1 times 1. And when I hit enter, I come up with 1.17 times 10 to the 11th to three significant figures. So I'm going to write that down here. 1.17 times 10 to the 11th, and that's miles per hour. Now, that answer turns out to be wrong, and here's why. If I look carefully at my calculator screen, I see that what I've really told the calculator to do is to take 13.0 times 100 times 60 and then multiply it by the fraction 60 over 2.54 and then multiply that by 12 times 5,280. And that's because your calculator always does divisions first and multiplication second unless you tell it otherwise. But what I really wanted it to do was do the multiplications on the top and the multiplications on the bottom first separately and then divide the two products by one another. Now you can do that manually. You can calculate all the product on the top and you can calculate the product on the bottom and then write them down and then divide. But your calculator has a feature that allows you to get out of that. Watch carefully. I start out with 13.0 again, times 100, times 1 times 1 times 1, times 60, times 60. Now, I'm going to hit enter and do that calculation. There's my product. Now, when I hit divide by, I'm not going to start multiplying. I'm going to put a parenthesis in here. Now, that's telling my calculator, do the multiplication that's in the parenthesis first, and then divide by 46,800,000. So now I put in 2.54 times 12 times 5,280. Close my parenthesis, and then hit enter. Now you can see this answer is substantially different from the last answer. Instead of something times 10 to the 11th, I now just have something times 10 to the 1, basically. The answer to three significant figures is 29.1. So that's the correct answer, and I got that by putting parentheses in before I multiplied the product that's in the denominator. It's called order of operations, and your calculator isn't smart enough to know what you want it to do. You have to tell it. So my answer ended up being 29.1, and this was miles per hour. Okay, you try this one. I think you can use the same factors that we used before. I'll just refresh your memory. 2.54 centimeters is 1 inch. 5,280 feet is 1 mile. And 100 centimeters is 1 meter. Stop the video, work it out, and then I'll give you the answer. Well, as always, when I'm doing dimensional analysis, I start out by writing down what I know, which is 90 with a point. I want to keep my sig figs there. Miles per hour. That means divide by. Don't forget. Over here, somewhere, my target unit is going to be meters per second. Well, I'm pretty much doing the opposite of the last problem, so I'm going to use a bunch of the same factors, but they'd probably be flipped upside down. Let's work on the numerator first. I want to get miles converted into meters, so I'll start out with this. 5,280 feet is 1 mile. I'm doing this so I can get to inches because I know inches are my way to convert to the metric system through centimeters. So 1 foot is 12 inches. If I stop there, I'd have inches per hour. But 2.54 centimeters is the same thing as 1 inch, so now I've converted into centimeters per hour. I want meters, so I have one more step for the numerator, and that is 100 centimeters down here is the same thing as 1 meter. Centimeters drop out, and now I have meters per hour. But I want meters per second, so now it's time for me to start working on that denominator. 1 hour is the same thing as 60 minutes. So this factor will get rid of hours and change me into a unit of meters per minute. One step to go, and that is that 1 minute is 60 seconds. Now I've canceled off minutes. Everything is canceled off except the units I want. Meters in the numerator, seconds in the denominator. Seconds in the denominator. Now, since my dimensions come out right, since my units are correct, I can be very confident that unless I push buttons wrong on my calculator, I'll come up with the right numerical answer. You work this out, you should end up with 2 significant figures, and here's why that's the case. All of these factors are exact. These are all definitions, so they have infinitely many significant figures. The only thing we have to think about is that initial measurement that we started with, and that's 90 with a decimal point. That's to 2 significant figures. That's 40 with a decimal point after it to give me 2 sig figs meters per second. And there's your answer. Well, this tool and the one in the last video, the APCE method, I hope you really take these to heart and start solving problems using them. At first, when the problems are easy, it seems like a cumbersome thing, like it's something extra that you have to do, or like it's a bother, some requirement, but it really isn't. This is how you solve problems. When they become more complex, you need tools like this to analyze your problems and to help you get around some of these procedural difficulties like converting units. And these 2 tools are extremely valuable. I recommend them highly.